Okay, completely different measurement here. So now we're talking about pyrometers. These are devices used to measure high temperatures. For example, in steel making and metal forming, I took up this photo and notice in here, it might be hard to see, that says 1249 C. This is a steel forging process that I was involved with, Williamson brand pyrometer. So there are really two major technologies. I'm not going to get into them. One's called an optical, the other's called an infrared. And even within these divisions, there's subdivisions, different technologies, slightly different technologies. So optical and infrared are the two major types. Any of these use this concept of emissivity. So emissivity is the ratio between the actual energy emitted from a target and that of a black body emitter. So this is a concept in physics you can learn more about, but the emissivity of a lot of metals and things it tends to be very high, like 0.9 or something like that. So anyway, that's just an important thing to know, how high temperatures are measured. Other types of measurement, these are inline laser micrometers. They're called scanning laser micrometers. So in other words, there's a laser head in one of these ends, and this is in two directions, X and Y. So there's a laser that's zipping back and forth on a little motor very fast, and then there's a sensor on the opposite side that's picking up. It's using that scanning laser to measure the part. Right here is an example of a crosshead scanning laser micrometer. Very fast, high frequency. So you can see this is some extruded cable, wire of some kind, and the head is scanning, but part of the laser that's being emitted doesn't show up on the other side. Well, that information, the missing part of the laser, is then used to generate a outside diameter measurement for this wire. And then you get two of them and you can measure things like ovality and things like that. So anyway, crosshead, a scanning laser micrometer, very fast, operates in real time. You can get multiple measurements out of it. So very useful tool in a lot of things, extrusion and wire making and things like that. Provides an estimate of roundness. I already mentioned that. Pipe, tubing, filament, wire rope, all sorts of things. Okay, and then just other examples, machine vision utilizes the cameras and optics and lighting and digital image processing software, has definitely become more popular in the last decade or so. It's essentially taking a video or taking a photograph and then applying some sort of measurement algorithms to the photograph, and it can pick up the presence or lack of presence of components. It can measure things directly. It can do all sorts of stuff. Machine vision is a big deal. Here's a video of some nuts here. Notice the lower right, it's taken a photograph and then it's measuring some features. It looks like maybe an outside diameter, inside diameter, and it's doing it fairly quickly too. And all these analytics, and you get photos. And if it detects a bad part, it rejects it, and you can tie that, send out a signal to some sort of arm, and it kicks it out of line. So you can do a ton of stuff with vision these days. Vision systems are designed for vision inspection and control in industrial applications that require high speed, high magnification, 24-hour operation, repeatable measurements. It really is a very, very useful tool and has gotten much more sophisticated in the last, 10 years or so. So interesting technology. So applications include positioning, identification, verification, flaw detection is a big one. Measurement is a big one. That is the end of this lengthy section, measurement and test equipment. Let's take a little break, and then we'll move on to the next major section.